Welcome to the SOFiSTiK online documentation. In this video of the composite bridge tutorial, we show how to calculate shear forces for the design of the shear connection between structural steel and concrete. According to Eurocode, these shear forces should be calculated using the properties of the uncracked section, even in areas where the concrete acts in tension. For this purpose, we provide a special task named bond that uses uncracked section properties for the calculation of stresses and bond forces in the section. You can see here that we first do the calculation for the ultimate limit state design load cases, superposed to give maximal and minimal shear force we set. As we have already used these load cases for the ultimate limit state design checks, we will store the new results for the uncracked section properties under different load cases. Therefore, using an offset for the result load cases, here for example 20,000. Typically, the design of the shear connection has also to be checked in the serviceability limit state under the rare combination. For this purpose, we run the task a second time, now using design load cases of type rare. Okay, let's take a look at the results. You can see for each load case, the task prints the shear force in the shear connector along the design element, and also plots the shear force along the design element. You can also here, for example, see that I requested a detailed information at a section at x equals 15.99 meters, so at the inner support. And here we can also check the stress and the distribution of the shear forces in the section. And as you can see here in the first plot for the axial stresses, the concrete remains active even if it acts in tension. Compared to the previous tasks, the second plot does not show the shear stresses, but the shear forces in the elements. You can see that the shear connector here is highlighted in green. Now you can take these shear forces and proceed with the design of the shear connection. For example, calculating the amount of head stud anchors via an Excel file. Please note that the shear forces calculated here are computed on the cross-sectional level purely from the shear forces and the torsional moments in the section. Local effects, like the effects of concentrated axial forces applied to the section or effects from sudden changes in the cross-section, like for example depicted in figure 6.12 of Eurocode 4, are not considered and have to be treated by the user separately. Okay, that's it about the shear forces for the design of the shear connection. In the next video, we will show you how to calculate stress ranges for the fatigue design checks.